Today we are going to talk about polynomial functions, and the main focus of this lesson and this quiz is on being able to distinguish which graph could match with an equation and vice versa. So there are going to be a lot of questions that just either give you a graph and give you some choices and you have to pick the one that could be the equation, or they give you an equation and they're asking you to match the graph. So we are looking at four different main types of polynomial functions: linear, quadratic, cubic, and quartic. And the way that the graph looks is going to depend on several things, but the main thing that they're focusing on in this lesson is whether the leading coefficient is positive or negative. Remember that the leading coefficient is the coefficient of the highest exponent term. So the one that has the highest power, that particular term, its coefficient is the leading coefficient. If it's in standard form, it'll be the first one, which is why it's called leading. But you do need to be careful because they don't always have them in standard form. So linear, that's pretty easy. If the leading coefficient is positive, that means that the slope is positive, which means that you're going to have a line that rises to the right. If the leading coefficient is negative, which means the slope is negative, that means you're going to have something like this. Now again, this is just a general shape, so I've just drawn them on the coordinate plane. It doesn't necessarily mean that the y-intercept is always going to be above 0. It could be below, it could be on the axis, any of those things. But it's going to rise to the right if it's positive leading coefficient. It's going to fall to the right if it's negative. One of the other things that they're going to ask you for is the end behavior. And so that's part of being able to pick the right graph. So if something is linear and its leading coefficient is positive, what you would say about the end behavior is that it starts low and ends high. So starts low, ends high. Negative leading coefficient is the opposite for linear. It starts high and ends low. Quadratic, these are our parabolas. So again, where the parabola is in the coordinate plane isn't what we're focused on. We're focused on the shape. So if you have a positive leading coefficient, your parabola is going to open up. If you have a negative leading coefficient, that means that your parabola is going to open down. Again, we could move and shift these around anywhere. We could shrink them, we could stretch them, but we're just focusing on which direction it goes. So when it's a positive leading coefficient, it opens up, which means that it starts high and ends high. Whereas a negative leading coefficient starts and ends low. Cubics. So cubic, the general shape looks something like this. Now, sometimes it could just simply be this with a little less curving in the middle. So these are called a relative extrema. So a relative maximum and a relative minimum. They're just like the little roller coaster hills and valleys that we get when we get higher exponents. So how steep these are is going to vary. So you could have a cubic, let's say, that, looks like this. This would have a negative leading coefficient, but you can see how this hill is really skinny and this valley is a lot fatter. That doesn't matter. So these ones, they're kind of even here, they're kind of squished. None of that matters. What matters is the general shape, that in a cubic, you have ends that go opposite directions, but you've also got a turning point in the middle where it's changing directions. And you can have a hill and a valley. No more than one hill and one valley, though, on a cubic. The end behavior, if the leading coefficient is positive, starts low, ends high. For negative, it's the opposite, starts high and ends low. Finally, quartics. So quartics, we're just going to add another little hill. So a quartic with a positive leading coefficient is going to look maybe something like this. So see how it's got two valleys instead of just one, and a hill there. If I had a negative leading coefficient, then I'd have two hills, one valley. So here, end behavior, both ends go up. So it starts high and ends high. And starts low, ends low. So again, matching and stating end behavior is going to be one thing that you need to be able to pick out which equations could go with which. Another thing you're going to need to be able to do is an evaluate a function for a given value. So for x equals 2, that would mean I'm finding f of 2. And that just means plug in 2 in place of x. And that's everywhere that there's an x. So that's going to be my first step, is just to plug it in and do nothing else. Then I'm going to use my order of operations. Exponents come next. So 2 to the third power, 2 times 2 times 2 is 8. So I have 2 times 8 minus 6 times 2 squared, which is 4, minus 11. Then I do the multiplication. So 2 times 8 is 16. Negative 6 times 4 is negative 24. So then I have 16 minus 24, which is negative 8, minus 11, which gives me negative 19. And so f of 2 would be negative 19 in this case. Example 2. We're going to be finding several things. It looks like I forgot to paste the picture in here, so let me just grab it over here after I read what we're finding. So based on the graph that I'm going to show you, we're going to find the values of x for which f of x equals 0, and then we're going to find a relative minimum. So the values of x for which f of x equals 0, remember that f of x means the same thing as y. So we're finding the x's where y is 0. So we're looking for where the y coordinate is 0. These are going to happen at the x-intercepts here. Relative minimum, what a relative minimum is that I described when we talked about the cubic, is the bottom of a valley. It's the point that it's the bottom of the valley. So if I were looking at this graph, a relative minimum would be right here. A relative maximum would be right here. On this quartic, I have a relative max here and here, and a relative minimum down here. So it's not the very lowest or very highest point always, but it is the top of a hill for a relative maximum, the bottom of a valley for a relative minimum. So we're looking for the bottom of a valley. All right, so let's look at the picture now. So when we're trying to find the values of x for which f of x equals 0, y equals 0 at the x-intercept. So you can see that there are 3 of them marked right here. So here it just says, it doesn't say find the x-intercepts. Those would be ordered pairs. It says find the values of x for which f of x equals 0. So it looks like we've got negative 2, This one, we're going to have to estimate. We can't tell exactly where it is. It's definitely a little above negative a half, so I'm just going to say negative 1/4. On the quiz, I think they even label the x-intercepts for you, so there shouldn't really be guessing. You just look at it, look at the x-coordinate, and list it. And then this one is at 3. So over here, I would say x equals negative 2, negative 1/4, and 3. The relative minimum then, bottom of the valley, is going to be right here. And again, I have to estimate this because it's kind of between, but it looks like it's maybe at about negative 1 1/4. And if this is negative 10, this would be negative 15. So let's just call this negative 12. So negative 1 1/4, negative 12. And that would be our relative minimum. If they had asked us for a relative maximum, we would look up at this point and we'd say, okay, that looks at like it's about 1 3/4 and maybe at about 37 or so. So that's what it's asking for when it asks for a relative max or min. Example 3, describe the end behavior of f of x equals negative x to the fourth plus 3x squared minus x plus 1. So we talked about end behavior when we had the graph. Now we need to be able to decide that based only on the equation. So really all you need to do is use what's in this chart, because the highest power that I see in this polynomial is 4. So because it's degree 4, that means it's quartic. And the leading coefficient is the coefficient that goes with the highest exponent, so the degree 4. The coefficient there is negative 1. So that means that a quartic with negative leading coefficient is going to look something like this. So I don't even have to graph it if I don't want to. Now, certainly you can, if that just helps you and it makes you feel better to look at the graph. You can type this into Desmos or into your graphing calculator if you want. But just based on the equation, we know that the end behavior is going to start low and end low. All right, make sure that you reach out if you have questions, and that's it for this lesson.